In this lesson, we are going to talk about all of the key features of quadratic functions and how to find them. So this means we're going to be looking for the roots and the zeros. Another word for that is the x-intercepts. So the zeros are where a quadratic crosses the x-axis. That's why these are also the x-intercepts. We're also going to be looking for the y-intercept and the vertex. Now the vertex is important because from the vertex we can tell whether or not the function has a maximum or a minimum. We can also find the axis of symmetry, and we can also determine our domain and range, all by using that vertex. So let's jump in and do our first example. So here we have all the different things that you're going to be asked to find: the zeros and the y-intercept and the vertex. All of that I have listed for you here, and we're all going to find that from this picture, okay? So let's start with the zeros. Remember that another word for the zeros is x-intercepts. Sometimes you're also going to hear them called the roots, okay? Depends on who you're talking to and where you're finding the question. So the x-intercepts, of course, are where the quadratic crosses this x-axis. So that would mean my points here and here. So this one right here is -5, 0. And this one right here looks like 1, 0. Notice that when you're looking at intercepts or zeros, your y-coordinate is always 0. So our apparent zeros are -5, 0 and 1, 0. All right, the next thing that we want to look for is the y-intercept. So on the opposite side of finding the x-intercepts, we're going to look for where the quadratic crosses the vertical axis. So that would be the point right here. This time our x-intercept is going to be 0, and it looks like we are up 5 spaces, so our y-intercept would be 0, 5. Cool. Those should be simple. We've been doing those since Unit 2, being able to find those key features. So now let me erase this and let's go find the vertex. The vertex is like the most important point on a quadratic. And the rest of this is actually very similar to, if you remember finding key features, from an absolute value function. It's very similar with a quadratic. It's just a different shape, but all of those key features are pretty much the same. So the vertex is kind of that turning point in a graph where we're going up, 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 and then it stops and it turns and goes down, right? So our vertex is this point right there. So we've got to find our coordinates. So it looks like I'm going left 2, so that would give me a -2, and then I go up, what is that, 9? So my vertex here is -2, 9. Now, tell me whether or not this is a max or a min. Think about it. Remember that a minimum would be the lowest possible value, and a maximum is the highest possible value. So does this vertex have a low value or a high value? This vertex is at the very, very top. That means it is a max. But then we need to tell what the value is. The value is how high it is from the origin or how low it is if it were a minimum. So what is the value of that y-coordinate? Well, our y-coordinate was 9, so then our maximum is 9. Let's erase that work now, and let's look at our axis of symmetry. Now, just like absolute values, quadratics are symmetrical. That means you can fold them on top of the other side, like right down the middle. If you were to fold it over, and one side would lay on top of the other. So think about that. If I go right through the vertex here on my dotted purple line, if I were to fold that, like if you have a piece of paper and you were to fold that over on that dotted line, do you see how this side would fold over on top of this side? That means they're symmetrical, and that dotted line is your axis of symmetry. It's that line that it reflects over. So that means that our axis of symmetry is an equation. Now think back to what type of an equation vertical lines are. They're always an x equals equation. Well, it's along that vertex, so what would be the coordinate be all along that dotted line? It would be -2 because anywhere along this line is -2. It also happens to come from our vertex. So between your maximum and your axis of symmetry, you actually are using the same coordinates as your vertex. You see that? Cool. The last thing we got to talk about is our domain and range. Now, domain should be simple. Let's talk about this. We've got an arrow going this way. That means it's going down, but it's also kind of going to the left. Do you agree? Then I've got this arrow over here. It's going down, but it's also going to the right. When we're talking about domain and range, we're only talking about left to right. So let's start with our farthest left point. Our farthest left point is this arrow, which is going to the left. If it's constantly going to the left, where do we say it's going? It's going to -infinity. It's never going to stop. That's why we have the arrow. And remember that infinity needs to be closed with a parentheses. Then, when we go to our farthest right point, again we have an arrow, but this time our arrow is going off to the right. So where is it going? It's going to infinity. Then we've got the range. And remember that the range is the lowest to the highest point. So if we look at the bottom, down here along the bottom, I've got arrows. Where are those arrows headed? They're headed to -infinity. And then we're going up, and we've got to look all the way up to my highest point, which was our maximum. And what was our maximum? Our maximum was 9. That's the tallest point we have. There's nothing higher than that. Now remember that you have to close an actual point like 9 with a bracket, not a parenthesis. It's very important. Cool, so that's all the key features we have to find. Now, these should not be new to you. We talked about all of these in first semester when we were talking about absolute value. The only difference is instead of a V shape, quadratics make more of a U shape. They make a parabola. So let's try another example. If you look at example 2 with me, we have another picture. This time it's opening up and it's got a vertex below the axis, so it's just in a different position, but we can still find all the same information. So let's start with our zeros. Remember that the zeros are what? The x-intercepts. So we're going to look around our x-axis and we're going to find where the quadratic crosses, which would be here and here. So what are those coordinates? Looks like -3, 0, and 1, 0. Then we go find our y-intercept, which is just on the other axis, and this time there should only be 1. So we look for where the quadratic crosses that line, and that would be here. And so this time, remember we always start with 0, and then it looks like we're down 1, 2, 3, so 0, -3. Now I do want to point out that they're not always backwards of one of the zeros. I know that in example 1 we had a similar x-intercept to a y-intercept, and in this example we have a similar x-intercept and y-intercept, but that's not always the case. They can be completely different. They have no correlation with each other at all. All right, now let's go find our vertex. Our vertex, remember, is that turning point. So it's where we're headed down, and then it switches and it goes up. So that point right there would be our vertex. So right here. So my coordinate there, it looks like I'm going left 1, which would be a -1, and then down 4, so -4. Now, when you're looking at that, would you say that that point is the lowest value in the function or the highest value in the function? It's definitely the lowest value in the function. There's nothing lower than that point. So would this be a maximum or a minimum? It is a minimum because it's that lowest point. Minimums are always at the bottom. And what would be the value of that minimum? Good. So the value of the minimum is always the y-coordinate from our vertex. So the y-coordinate of our vertex was -4, and so our minimum is -4. Now let's talk about that axis of symmetry. So if you remember, the axis of symmetry is that vertical line. It's a vertical line that we can fold our function over, or we can reflect the quadratic over to create our u shape. Okay, now it is a vertical line. So what type of an equation does a vertical line have? It has x equals. Great. And then we just go to our vertex and we take the x coordinate. Which one's the x coordinate? -1. Cool. So then we go to domain and range. Now domain and range, remember, one of them always is the same because we're going to have arrows always going to the left and to the right. I know it may not look like it because they're both going up right now, but they're going up and to the left and up and to the right. Or like in our last example, it was going down and to the left and down and to the right. So if this is always going always to the left and always to the right, our domain is always going to be -infinity to +infinity. Guys, if nothing else, you should get that part right because it's always going to be the same when you're talking about a quadratic function or an absolute value function or a linear function. They're always going to go from -infinity to +infinity. Okay? Then we've got to take a look at our range. So remember that we do have the lowest point, right? We were talking about a minimum. We always start range with the lowest point, which happens to be our minimum. What was our minimum? It was -4. So we're going to start at -4. And does that have to open with a parentheses or a bracket? It is a bracket. Now, this is going up and up, up, up with arrows. Where are those arrows headed? They are headed to infinity. And we close that with the parentheses. Awesome. So we are well on our way to being really good at this, just like we were in Unit 4, right? Let's try number 3. So in number 3, this one looks a little different. First of all, I took the dots off, but that's okay because anywhere you see a line, there can be a dot. You can make your own dot. It's going to be okay. Let's start with the zeros. And again, another word for zeros is x-intercepts and also roots. So you can see any of those words used interchangeably. So let's start by finding them. If you remember, x-intercepts are going to cross the x-axis. Look at this. Does the function cross the x-axis? No. So can we say there are any zeros? No, there are none. So we're just going to write none. Or when you take your assignment online, pay attention. You may need to say something like no solution, not available. Just look at your directions, okay? But there are no x-intercepts. Please don't put 0. Because if you put 0, that means it crosses at 0. And it obviously does not, right? So just put none. Then we got to find our y-intercept. Now, just because there were no x-intercepts doesn't mean there aren't any y-intercepts. We've actually got to look at that line. So here is where my y-intercept is. What is the coordinate for that? It is 0, -5. Wonderful. Now let's go find our vertex. Remember, your vertex is that turning point. It's usually your max or min. Actually, it's always your max or min when you're talking about a quadratic. So that would be this point right here. And what is the coordinate for that? It's over 2, so that's a +2, and then down 1, so that's a -1. So would this be a maximum or a minimum? It is a maximum. It's at the top. And what would be the value for that? -1. It's always the y-coordinate from our vertex. Awesome. Let's look at the axis of symmetry. Remember, that is that vertical line that goes through our vertex. So would this be an x equals or y equals equation? Because it is an equation. It is x equals. So then which coordinate from our vertex would we choose? The x coordinate, which is 2. Let's go back and find our domain and range. So let's start with our domain and range, which you should already know. It should just be memorized. Negative infinity to positive infinity. And again, that's because of these arrows, right? These arrows are going down and to the left, and over here down and to the right. So it's that left and right that creates your domain. Then the range, so the range, we always start at the lowest point. So the lowest point here would be those arrows, and arrows that are going down tell us that it's going where? To negative infinity, but it's not going up to positive infinity. What's our highest point? Remember, we had a maximum, and that maximum was -1. That means that that is the maximum height we can reach in this function. So our range goes from negative infinity to -1. All right, I want you to pause the video and try this example on your own. So let's start by finding the apparent zeros. This time, I hope you got this, there is only one place where it crosses that x-axis. The point is -1, 0, and that's it. It doesn't cross anywhere else. The y-intercept is where it crosses the y-axis. That would be at the point 0, 1. Now, this is a unique situation where our vertex is actually the same as our zeros. Our vertex actually sits on the x-axis. So our vertex is actually the same as the x-intercept. It's -1, 0. Now, this is at the bottom, so this is actually a minimum, and the value is 0. Our axis of symmetry, remember, we'll always start with x equals. It is an equation. An axis has an equation. So this would be x equals -1. Our domain, always the same, negative infinity to positive infinity. And then our range, remember, this had a minimum. So we start with the minimum, and then we go up. And we're going up to infinity. Awesome job. Let's go ahead and move on to some practice.